Okay, we're continuing from the first video on the Bronsted-Lowry acid-base lab where we use the pH meter. And what we're doing here on the second page, first of all, we have to make a couple of corrections. So let me get in here nice and close so you can see what I've crossed out. I want you to cross out the words on your calculator because we're not using calculators to do our calculation. And what I'm looking for right here is that you describe to me how you are going to take the how you're going to find the pH of each solution and what your calculation is all about, how you do it. So you got to show me how to use the little chart, or you got to talk about how we use the little chart to change concentration into pH. And what we're doing there, of course, is taking the minus log. And we're doing it with a log table that has the logs of 1 through 10 and using it in conjunction with the concentration and taking the exponent of 10 as the first number. And this is all described in my other videos that I put up that deal with how to calculate this stuff. So I just want a description of that here, and it needs to be a brief description. Now down here in number 6, why is the calculated pH for D, which is this line up here, why is our calculated pH different from the pH meter? Well, it's not. So you want to say in here, it's not the same, and I want you to tell me why. You want to say because I figured out that the calcium hydroxide was a base, first of all, not an acid, and so I calculated that properly. I also figured out that there's 2 hydroxides here. And what that did was it took my concentration of 0.05 and doubled it because each calcium hydroxide carries 2 hydroxides. This is the concentration of the whole thing before it separates. Now it separates 100% because it's a metal with a hydroxide. And that means that this guy is going to actually be 100% separated, giving us 2 hydroxides for each of these calcium hydroxides that we started with. And so when we're talking hydroxide concentration, that baby's going to be double this number, or 0.1. So you're going to take that as the concentration and do the minus log of it, and that will give you the pOH because this guy is a hydroxide. Now to get the pH, you have to take and subtract that pOH from 14, and that will give you the number that you see here. And then the last thing down here to change is, or not to change, but to make sure you understand, you're supposed to calculate the total hydronium ion concentration. Now, hydronium and hydroxide are the same thing. Not really, but for our purposes of calculation, when I say calculate this guy, it's the same as if I say calculate this guy. Okay, so they're both the same thing. So I'm going to calculate the actual hydrogen or hydronium ion concentration for each solution. What is that, each solution? That's all of these guys. That means we go from letter A down to letter J, taking the pH numbers that we got off the meter and figure out what the hydrogen ion concentration is. So in that case, we're doing the anti-log, or we're finding the concentration from the pH, which is the same thing. So what you want to do is, look, if you don't know how to do that, I have a video that shows how to do that, and you can see that in the homework page. So that will be available for you tonight. In fact, it's up before I made this one. So you're going to calculate A, B, C, D, E, F, G, H, I, J times. You're going to calculate the pH, or the hydrogen ion concentration from the pH. So that's what your job is in that part of the lab. Now, to finish this thing off, I want to make sure that you understand if you expect to get any credit for this lab, when you do your calculations, you want to do it in such a way that I see the calculation given for each thing. And I'm looking for that right now. I had a paper that showed that. There it is. So let's take a look at this. And as I look at this, I'm seeing that I've labeled from A down to J, and that's where I'm going to do calculations, and I'm going to do them just like this. Your A, you had a given nitric acid concentration of 0.05. That had to be converted to scientific notation to make my little method of logarithms work. So now we have 5 times 10 to the minus 2. That minus 2 changes sign and becomes positive 2. And then we take 5 and look on our little chart, and that little chart will tell us that the logarithm of 5 is 0.7. And that 0.7 has to be subtracted from the 2 to get the pH. I want to see that for every one of these. Anyone that doesn't have this, you'll receive no credit for. And this is a 20-point lab. Now let's look at probably the hardest one you were given, and that's this guy. It was the calcium hydroxide concentration of 0.05. But, as I said in the first video on this lab, this is doubled because we have 2 hydroxide ions for each calcium hydroxide. Calcium hydroxide is the complete compound, and we have 2 hydroxides in each one of those. So whatever the concentration of this was, I'm going to have twice as much when I'm talking the hydroxide ions. So I have a 0.1 molar concentration, and in scientific notation, that becomes 1 times 10 to the minus 1. And so that guy, I'm going to take this guy for my 1. The log of 1 is 0. So note that this number right here is a pOH and not a pH. So to get the pH, I have to subtract that number from 14, and that gives me a pH of 13. All right? So we're all on the same page with that. I wish you the very best luck with this lab. Hope it doesn't keep you up too late like it's keeping me up right now. And we'll see you all in the morning. Good night.